Hello everyone, in the series of methods of finding the answer to the system of two equations, today we're gonna take a look at the other way, which is called the matrix inverse. As it seems so, we're gonna take the matrix inverse of something and probably just need to take some more necessary steps to solve our system. This method seems to be kinda hard, but not for the one who is watching this video anymore. You only need to do some more examples just to get much more acquainted and be able to solve these type of questions just more quickly. Consider this system with these simultaneous equations. The first equation is a1x plus b1y equals c1. And the second equation is a2x plus b2y equals c2. I suppose you know how to write simultaneous equations in matrix form, but no worries that I'm gonna mention it again here. Provided that you know how matrices are multiplied together, you will easily realize how this system can be written in matrix form. Okay, the first thing you need to do is to find the matrix of coefficients of unknowns in the system. Our unknowns in the system are x and y, and we need to find them. And the coefficient of our unknowns in the first equation is a1 and the other one is b1. Okay, they came to the first row as you are seeing here. And in the second equation we have a2 and b2, and it goes to the second row, okay? So it's gonna be a1, b1, a2, and b2. We're gonna name this matrix the matrix A. And then we multiply this matrix by the matrix of our unknowns, which are x and y. This is the vertical matrix, which is gonna be equal to the vertical matrix of our constants actually in the system. Our constant in the system are C1 and C2 in the second equation. And we are gonna name this matrix B. We're gonna call this matrix of our unknowns the matrix X, so that A times X is gonna be equal to B. Okay, and in here we're gonna see where this procedure has come from. Okay, from here we have ax equals b. We need to just multiply both sides of this equation by a power negative 1. A power negative 1 is the inverse of the matrix of coefficients of our unknowns. So it's gonna be a power negative 1 times a times x equals a power negative 1 times b on the right side. So that we will have a power negative 1 times a, which is equal to the identity matrix. Identity matrix actually is a matrix whose product with another matrix A equals the same matrix A. And also is a square matrix which contains ones along the main diagonal from the top left to the bottom right, while all other entries are 0. So in here, a power negative 1 times a is gonna be the identity matrix, and because a is the 2 by 2 matrix, so I is gonna be 2 by 2 here. And as I told you, the product with another matrix A equals the same matrix. So if an identity matrix is multiplied by another matrix, the answer is exactly the matrix itself. So I times x is gonna be overall x, and on the right side we have a power negative 1 times b. Okay, so that x is the vertical matrix of our unknowns, which is x and y here, equals to 1 over the determinant of this matrix multiplied by the matrix of switching our entries in this diagonal, and keep the entries in this diagonal in the same place, just switch the sign, so it's gonna be negative b1 and negative a2 here, times the matrix P, which is our constants in here, so it's gonna be C1 and C2. And now here there is an example, okay, with these following equations. This is our system. The first equation is 5x minus y equals 6. 2x plus y equals to 8. First, we want to just write these simultaneous equations in matrix form. The matrix of coefficients is equal to 5, -1, here we will have -1, 2 and 1 here, and our unknowns are x and y, so the vertical matrix of our unknowns gonna be x and y equals to the vertical matrix of our constants, which in first equation is 6 and in the second equation is 8. So we only need to find the inverse of the matrix of coefficients of our unknowns here and multiply it by the vertical matrix of our constants to find our x and y here. So x and y is equal to 1 over the determinant of this matrix, which is equal to 5 times 1 minus -1 times 2, which is going to be 5 plus 2, overall is 7. So 1 over 7 times this matrix, the matrix of switching the entries in this diagonal, it was 5 and 1, so it's going to be 1 and 5 here. And switching the signs in this diagonal, but keep them in the same position. So it was -1 and 2, so it's going to be 1 and -2 here, okay? Times the vertical matrix of our constants here, 6 and 8, so it's gonna be 1 over 7 times the, actually we're gonna multiply these two equations here. This is a 2 by 2 matrix and this is 2 by 1 matrix, and the answer of this is gonna be 2 by 1. Actually it's gonna be the vertical matrix itself. So we're gonna multiply the first row by this column here. It's gonna be 1 times 6 plus 1 times 8, overall 14. And again for this row we're gonna multiply it. It's gonna be -2 times 6, overall -12, plus 5 times 8, which is gonna be 14, so -12 plus 14, it's gonna be 28. So 1 over 7 times 14 and 28 here, this is our vertical matrix, and x and y, which is gonna be 14 over 17, 2, and 28 over 7, it's gonna be 4, so our x is gonna be 2 and y is gonna be 4 here. We can also check our answer by substituting x and y in our equations in the system. So it's gonna be 5 times x, which is 2 here, so it's gonna be 10 minus y is 4, so it's gonna be 10 minus 4, overall is 6, which is true. And 2 times x, which is 2, which is gonna be 4 plus y, and y here is 4, overall 8, and which is correct here. So the answer is overall correct.